You don't need Python.
And mine requires the visual space or whatever it is.
It doesn't require you choose it. You visual machine, custom and
Visual machine.
Do we need the visual
Yeah,
thing?
pick and choose.
Because on the link, he selected visual and Python, but it didn't work for my computer, so I just did default. And those two were just like, let's uninstall the visual. Okay.
They want to create their home tab.
I don't know what's Python.
Simple instructions. It works 90% of the time, but 1%, it's actually easier for them to follow.
SQL Server?
But if you,
That's another product. If you want to use SQL Server, that's fine. But that's my SQL. It's a different product than SQL Server.
Yes.
So, it's up to you what you want to use. I'm telling you this is the easiest one to use.
Yeah, you got cloud, right?
so if I just open one,
Do you have your database?
What is your visual thing? Like, this is what you told me, Microsoft,
That's it?
I wasn't sure if anybody was saying like Oracle SQL just so that you connect it Oracle database on it, like to practice.
Alright, let's start.
Whereas this thing that he needs us to download it so that we can create our own database.
What do you add? That's a new one, like 1.0.
Yeah, so you should, I mean, the interface part is not.
Because the new, I wasn't sure that I downloaded one in the video or the new.
Yeah, I did the new one as well.
Because it seems like the old one.
I don't know how to run something. The one in the video, the one in the video is like 3 years old.
If I type something, it's like
I mean, okay, I'll take you. Let's wrap up this chapter, then when we get to the database, we discuss it. All right. Any questions so far?
I saved mine.
Any questions?
Huh? Sorry, I didn't hear. One more time.
A lot of questions, but on the later chapter.
A lot of questions from which chapter? We have to finish chapter 12. So we're going to go to chapter 12 now.
Oh, we haven't told, like, he didn't tell us when actually we need to, like, when exactly we need to call the exception, right? Like,
Yeah, I didn't finish that chapter yet. So we're going to discuss it. Alright, so if you don't have any question, I'm going to continue. Alright, so next week we have quiz, and next week we have another quiz.
That's 6. I thought we had 5.
Yeah, you already had 3, right?
I thought we took 4. The last one was 3?
we missed one.
We're completely out of sync.
Man.
From database side to programming side.
You told me to pick one, I picked you, now I'm trying to get back to the other one.
Alright. So we talked about exceptions. So you remember in interface abstract classes you
Right.
study? Are you doing the homework?
Yes, sir.
Due this weekend, right?
Yes. Wait, yes.
So we talked about exception handling, which it was incomplete, so I'm going to go through whatever we covered before. So we have a code here, and we have a I'm glad you told me, because in some of my classes I talk for 10 minutes, and after 10 minutes they say there is nothing there. So, all right. So if we think a code might throw an exception, we want to put it in a try block and using a catch block to catch any exception that it throws, right?
Right.
For example, int a, does that need to go in a try block?
No.
Not really. Don't put some stuff that never throws an exception.
Just put your whole code in.
Try, then I can say, for example,
A equals.
I don't know, I put another int e here. And I say a equals 10, then e equals 0, then I say system out print line, and I divide a by b, which that gives me an exception, right?
Right.
Which line? Line number 17. So every try should have catch, and you can have one or more than one, right? So I'm going to put a catch here, and I say, okay, I want to specifically catch specific exception, so I'm going to divide it based on specific exception. For example, I'm going to say here, arithmetic exception, and what exception is really an object. The object comes here and says, am I matching this kind of class? And if the answer is yes, it goes through this block and it's end of the story, which means if I have other catch, will it go through those catches? No, it won't. The one who catch, that's end of the story. Execute the block and continue where? After all the catches, right? So it always makes sense to put an exception here because we already know exception in Java are what? Class based. So as you can see, you have object and then throwable divides into exception and error. You don't care about the error because you can recover from error. That's the end of the story for your program. But the exception divides into what? Some other exception, and a group of exceptions are called what? Runtime exception or unchecked exception, right? Other ones are called what? Checked exception. The runtime ones, compiler does not force you to try and catch them. It might throw exception, but compiler. But the checked ones, you have to put it in a try and catch, all right? So I'm going to put an exception here, and obviously you want to do something here, like message the user or pop up a message that something went wrong, and then I'm just going to put something like this. 8, 9. Now, look at this one. We didn't talk about this one. This is an object, and you can just simply put it there. If I put it there, it means that object already has what?
Two string.
Already implemented, and gives the explanation about this problem. What is the problem, right? And I'm going to put that here too. By the way, can I put another X here? Yeah. So now, non pointer exception throws, right? So I run this, and I'm going to see what? Java lang arithmetic exception division by 0.
Wait, what is X? The EX exception?
Is that the object that will be caught here?
You probably can get to it. You can keep going.
Hmm?
You can keep going. You probably can get to it.
Alright, so are we good so far? So you put it in try and catch, so your program should never crash it, which means that exception should never get out of what? Main. Alright? Are we good? Now, I'm going to cover all of it, then we go through the slides, alright? So, now take a look here. How many catch we can have? As many as you want, right? But it makes sense to put one exception at the end, so anything that you don't catch explicitly, this one will catch it, right? Alright. We can have now another optional thing which is called finally. You open a brace, you close a brace, and finally is a block that is optional, right? Because I didn't put it there, right?
Right.
The block gonna get executed regardless you have an exception or you don't have an exception, right? So I'm gonna say here in finally, and I'm gonna write another one out of all these catches and say out of try. So what will happen here? Will you have an exception on line number 17? Will you jump here? It's a type of a division by 0 exception or arithmetic exception. Do you print the X?
Yes.
Do you print also in finally?
Right.
Do you print out of try catch?
Yes.
Yes. So finally, regardless, you have an exception. So if I comment this, what gets printed on the console now? In finally, because you don't have any exception, but finally always gets executed, right? And then you print this, which is out of try and catch. Now, a classic example or question that they're going to ask in an interview, you understand the finally. So finally is optional, right? Are catches optional too or no?
No.
They are.
They are?
I can remove
Oh,
those,
yes, but you have-
and I can have only finally. So can I have try and finally?
Right.
Yes. Can I have try and catch? Can I have only try? No. So try should come with finally or catch, one of them or both of them. Are we good? Alright, now a classic question they're going to ask you in the interview. So explain the finally, which you're going to explain. And most of the time, not most, but sometimes you get messed up with final. Final and finally are two different things, right? So what is the point of finally? Yeah, they're going to always execute, but what is the application of it? The typical example of application doing some cleanup. So I'm going to give you some example. In the database section, you're going to see that in order to connect to the database and run something, you have several steps. Load the driver, which in the new JDBC you don't need to do that, but load the driver, connect to database. Connect to the database, imagine that you have a water tank and you want to get water out of it, right? You create a pipe to that tank, right? This connection is like that pipe. Will it consume memory? Yes. Will it consume resources? Yes. So connection, you connect to the tank, you get your water, and then what? Discard that pipe, alright? So connect to the database, run query, and then what? Close connection. Do you agree? So database is the source of the data, right? Like a water tank. You connect a pipe to it, you get your water, and then you discard that pipe. You good? Now, can line number 15, 16, 17, 18 throw an exception?
Yes.
Yes, they can.
Yeah.
Imagine line number 17 throws an exception. Something is wrong with your query. So if the exception happens here, will you go and check this one? Yes.
It wouldn't depend on the type of exception.
Yeah, let's say it's not arithmetic
Oh,
exception.
oh, man.
But will it go here?
Right.
Yes. Execute whatever you have there. Will it go to the finally?
Yes.
Yes. Okay. But did I skip line number 18 because line number 17 threw an exception?
Right.
So did I close that connection?
No.
No. So did I keep that pipe open? So now imagine that run query is broken and people keep trying to connect and it all blows up here, which means throws an exception. Well, I'm creating pipe continuously, but I'm not closing them. Eventually your program will hang because you can't have unlimited number of pipes. Pipes consume memory and resources. So you have to close the connection. But is this a right place to close the connection? No, because there is a chance of line number 17 throw an exception. So where do I put this?
Finally.
Correct. You put it here, so it guarantees that what? You always close the connection regardless what happens. Typical answer you have to give for closing connection in the database for some cleanup. Something that you need to do it regardless your program throws an exception or it doesn't throw an exception, right? So far so good? So in a database I like to see your close connection where? In the finally section, alright? Good? Alright, so we talked about try and catch and finally now let's have a method here. Public static void test exception. Let's say int A. In bracket array new int 10. Okay, and array, let's say 12 which you know was a problem there. And that's it. So will that throw an exception? It would, right? Okay, now, I'm gonna call it here. Can I call the method here?
Yeah.
Let me remove everything. Alright. So, now let's take a look here. You have main method and you have a test exception method, which main calling the test, right? So when I get here, do I jump here? Yes. This one throws an exception, right? Do I need to catch this?
In the method.
In the method.
In this method, so
Yes.
you can go to main.
Do I need to catch this?
Yes.
That's debatable. If I don't catch it, this line throws an exception, right?
Number,
There is no-
number format?
No. I already have a bounds.
Oh, yeah.
There is a problem here, right?
Yeah.
So I'm not catching it, right? So what will happen is this bubbles up, that's the technical term. This exception will bubble up to where? To the caller. The exception now comes here. Is anything catching it?
No.
It bubbles up what?
To the main.
Out of the main and causes the program to crash. So if I don't catch it here, eventually I have to catch it one on the way when getting out of the main, right? Now this is what they do it in normal programming situation, alright? I'm gonna catch that. So I'm gonna put the try. I'm gonna put the catch here. Alright. So, if this is a library, which a lot of methods are library using, right? You agree? Did you use random? Did you use this, that? A lot of libraries, right? So there are lots of libraries that you're gonna use, and you're gonna use some of the methods from that library, right? Okay, will that catch the exception? So if I'm calling it as a user of this library, do I get that exception back? No, it's catching it, right? System out, print line, that's the exception. Did I catch the exception in this library or this method? Will that exception bubble up here anymore? No, I caught it, right? Do I have any control over that exception anymore? What to do to it?
It's already caught in the method.
It's already caught, right? So, it gives less flexibility to the user because the library or that method caught it, and this library is not written by you, so you don't have any control over it. You want to give more control to what? To the user of the library. So, the library will catch that, will do whatever it needs to do, print a message or whatever, and then what it does? It rethrow that exception again.
So what's the purpose of this?
The purpose of this is because some library action on the exception might not be what you were looking for.
Oh, so it can be different exception?
No, it's the same exception.
But
I'm rethrowing it so it comes here, right?
Yeah.
What I do here is I'm going to put what? Another try catch. Alright? And I will do
You handle it
whatever I want.
But why it says in the book that we kind of have to better like catch exceptions in the method rather than taking it to the main method?
I caught it here, but I rethrow it. See,
Okay, then how often do you have to do that? Like, is it only for certain exceptions, or I mean?
how often always? You want to give flexibility to the caller to do whatever he wants to do exception. Maybe I want to pop up a message there. If I use a library that doesn't have this, can I do that anymore? No. Maybe the catch part of this library is not desired for me. I want to do something different. So I say, okay, you as a library do whatever you want. Rethrow that back to the caller, which is me, I'm using your library, and I do whatever I want to that exception. Alright?
Right.
Why?
Yep.
Okay, I'll give you a real example. You give some money to your brother, to go and buy something. Money is not enough.
Organic.
Yeah, organic apple, sorry.
Right.
And it's not enough money to buy organic apple, we can buy non-organic, right? So something goes wrong there in the grocery store, and your brother just doesn't notify you what happened. Suppress it and come back home. Will you like this more? Or then your brother knows there's problem there, so exception happened in the method, and then comes to you and say, hey, there's a problem there too. So you get notified and you can take action on it too. Which one is better approach?
The second one.
Alright, so that's exactly the same thing. Imagine this one suppressed the exception in the way it wants
You got it.
and doesn't notify the caller. So the caller doesn't know what happened, it's suppressed there. Maybe it prints something, maybe it doesn't print anything, maybe it does something different, right? I want to have control on any problem that happens to the caller. You want to have a control on the problem and take an action that is desired by you, not decided by the library. Do you agree? Oh yes, it's a little bit more work, but always more flexibility is better, right? Everybody agree? Alright? So good?
I'm still confused.
Yeah, it feels like you're repeating steps.
What?
No, so don't say
Well, I
that you
understand
wrote
the
the
part
method.
where you gain
It's the method that
flexibility, but
someone else
I'm
wrote.
still kind of
They can
confused.
control it.
Do we have to like
But you don't know.
throw exceptions all the time?
If you write a method, the best approach is try,
See if it's
catch, retro.
Okay.
You can retro it in the main because your
Yeah.
program will go crashes, right? But if you're writing a method,
And rethrow it again.
retro it again and let the caller do something
So
to it
this is
too.
a good practice.
It's a good practice, yes.
Just because of private stuff.
Because in the book we kind of didn't understand that.
Are we still debating this or no? You agree it's a better approach to retro it?
I mean,
Yeah, it makes sense.
I see exactly why you would rethrow it. I wasn't debating it. I don't know.
No, I'm just saying.
It wasn't me.
No, I'm just saying everybody agree there is a benefit to retro it.
Right.
Everybody agree there is a benefit to retro it or there is no benefit to
There's a
retro it?
benefit.
There's benefit to retro it, right?
Yeah, absolutely.
Okay. So you can throw the exception, right? You can throw the exception, right? All right. Now take a look here. All right. So far so good.
Yeah.
Now, I can come here and say, throw exception. Did I said this method can throw an exception?
Right.
If I declare something like that, that exception that bubbles up to the caller becomes what? A checked exception. Does it become? A checked exception. Alright.
Yeah, because you were thinking it's
Yeah, I'm gonna go say this gonna throw an exception. I mean, of course, a possibility. Now it becomes a checked exception, which means if you call it, the compiler says, hey, you are dealing with a checked exception, what you have to do?
Try catch.
Try catch. Try and what? Catch. So anytime you say on the header of the method that throws exception, that method when you call it, is the checked exception, you have to catch it. Now, will it always throw an exception? No, it might not. But as soon as you declare it, when you call the method, the compiler says there is a possibility of dealing with a checked exception, you have to try and catch it. So did I try and catch it? You have another option, which of course, in this case not recommended, but in other cases might be a recommendation. Did I try and catch it? No. So you have an option to try and catch it if it's a checked exception, or declare in the header that this might throw an exception. But it's a bad practice because if something gets out of the main, it crashes, right?
So it's basically crash management.
Crash management. So when you say throws exception, it means now there is a chance of a checked exception coming out. But is that really a checked exception coming out? Is that a checked exception?
No. That's out of bounds.
Out of bounds is a runtime exception, right? But when I put it here and say throws an exception, I'm making it what?
Checked.
A checked exception. Because I'm saying, hey, this will throw an exception, right? So checked exception and unchecked exception is easy to convert an unchecked exception to a checked exception. In that method just says throws exception, it becomes now a checked exception, right? So are we good with method calls and exceptions here?
Yeah.
So in your project, the methods you write, you just have to try and catch and then rethrow it. So this is how I handle the exceptions in my project. Because for every exception, you have to give some messages to the user who do something, right?
Right.
So I will do it this way. See, we're going to discuss the GUI, right? The user interface. So you have user interface. You have fields, buttons, blah, blah, blah. You fill it out, right? And you submit it, right? So when you submit that, of course, there is a class that deals with the UI, right?
Yeah.
Because you write a class that shows the UI, right? So when you click on this button, for example, submit or register, blah, 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 then you get all this information,
Yes.
the data, right? And you will see how we get it, all right? So you have the data. You have the social security, you have the email, blah, blah. So is that a class? Yes. All right. Will you do everything in this class? No. You're going to make layers, as we discussed. What is layer? Layer is the logical division of your program so you can maintain and you can work on it easy. Is that related to UI?
Yes.
Alright, so this becomes the UI layer. Now I'm going to deal with what? Maybe business logic, right? So I'm going to write another class in another package, which what? Which lump this data into what? An object. Right? And we call this object value object or transfer object. Why? Because see, the object will have every bits and pieces that I need, right? Can you send this one small bits and pieces to here? Yes, but why you need to do that? Can I put everything in a bag and carry it to the next class? Yes, so you need to create a class that has every information that is needed, and then you call a method here, and you pass what? That value object here. So now you have every information that you need, right? Agree? Now you do the business logic here, right? But before that, maybe before going here, maybe you want to have another class, like you want to name it catch, or
If it doesn't match.
no, maybe you want to have another method here. See, I'm going to call method 1. Instead of method 1, I will say what? Inspect exception. Is that a method? It's a method, right? So I'm going to write another class called what? Handle exception. And the method will be what? Inspect exception. And inside that you will have bunch of what? try, and then catch, 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 catch. And then when you call this, then you call this method, right? So is that the central place to deal with exception and messages and everything? So which one is better? To scatter this all over the place with different messages, or you know which class handle all the exceptions, and you can tweak any message you want. Here, right? By the way, there are more into that because messages can change, right? And messages can be in different languages. They don't hard code the messages here. They take the messages out and put it in a file or a database or something, and then try to hook it up to this one. So anytime something changes, I can easily change it in this file or database and going and change the code, right?
And that file is in database? Stored in database?
No, it can be a flat file on the application, but it's easy to change it instead of coding and compiling and all those stuff, right? So we don't deal with that, but keep that in mind. That's the common sense. Anything that changes, you don't put it in the code. Anything that's changed frequently, you don't put it in the code, because then every change requires what? The deployment, the release, which is a process and takes time, alright? So we good? We discuss this more, but right now we understand that when we get the data, we make it a value object. You want to centralize it to another class. See, you're just hopping from one class to another class. Layers is nothing more than different packages. Package 1, package 2, package 3. They're all in one place, but different packages. So you put a couple of classes here, but classes have methods, and by method call, you can hop from here to here, and then from here to another what? Another class. Now this class will deal with what? Database. So you might have get user, and then pass what? Email, and it gives back to the user back, alright? So we're going to discuss that a little bit more in details, but this is overall, you create layers. Layers nothing more than separate packages. Inside that package you have methods, in classes and methods, and you hop from one class to another class and take what that class needs to do. And then you come back and show them the new one. Alright? So expectation is you have to be able to soon finish these parts. The middle part and the last part. Alright? Alright. So we discussed checked exception, unchecked exception, try and catch, and finally, and we can put it in the header, right? Okay. Let's see what we have here more. So this is runtime exception or checked exception. So runtime exception, errors and their subclasses are known as unchecked exception. All other exceptions are known as what? Checked exception, meaning that compiler forces the program to check and deal with the exception. In most cases, unchecked exception reflect what? Programming logic errors that are not recoverable. For example, a null pointer exception is thrown if you access an object through a reference variable before an object is assigned. An index out of bound exception is thrown if you access an element in an array outside of the bound of the array. These are the logic errors that should be corrected in the program. Unchecked exception can occur anywhere in the program. To avoid cumbersome overuse of try and catch, Java does not mandate you to write code to catch unchecked exception. You have to catch them, but usually unchecked exceptions are dangerous ones, right? Null pointer exception, you're not predicting to happen, right? Alright. So these are the errors. We don't deal with errors. Method. Method 1, you have try and catch, but method 1 inside the try calls what? Method 2. Method 2 has a header of what? Throws an exception. If something goes wrong, what it does? It just throws an exception. Is it catching it even? No, it's just throwing it back. Some methods you see in the libraries, they just throw the exception back. They don't even catch and do anything to it. Who should catch that? The caller. That's your responsibility. Array out of bound?
Yeah.
Index out of bound?
Yeah.
What about it?
I mean, is that the one, same as like throwing back, saying like, yeah, like that, might be wrong.
Let me get the question one more time.
You know, when you get out of bounds, they show you the message saying that your arrays or whatever are out of bound, right?
Uh-huh.
Is that the one, is the same as like throwing back the exception, like you?
No, that's the message of the exception.
Yeah, it's like throwing back to you, right? So you can see where it's from.
Throwing back to me. Internally, yeah, you can say that. You can say
Try
that.
to find an example so I can know, right?
Yeah, you can say that. Alright. Every method must state the type of the checked exception it might throw. This is known as declaring exception. Public void my method throws what? IO exception. Public void my method throws IO exception and other exceptions, right? So you can separate them with different exceptions, right? Very good.
So when you write a method, you go to the library and see where the exception is thrown.
If you want to separate them, if you want to take an action on those different exceptions, yes. But if you don't care about what type of exception,
throw
you
exception.
just should catch it as an exception.
But you said it's like a bigger one to catch everything, whatever it's from.
Yeah, it catches everything. But if you want to really take a specific action on a specific exception, you have to separate them into different exceptions. Most of the time you don't. Most of the time you don't. Or one maybe specific one, but the rest you can be bundled in one exception. When the program detects an error, the program can create what? An instance of an appropriate exception type and throw it. This is known as throwing an exception. Can I say throw a new one? Yeah, you can throw an exception. See here, did I throw an exception here because I caught it, right? I caught it, right? I can remove this and just say, I can do that, alright? If a less than 0, for example. Throw, exception is what? An object, right? I don't have that object yet here, right? So can I create one? All of those classes are exceptions, are classes, right? Less than 0. See, I created a new brand exception, an object. You know what is keyword new, right? You already know what is this. This is just a constructor, right? And then throw is a keyword to throw that object. You? Remove this. And then it becomes what? A problem, right?
Yes.
Then you have to try and catch it, right? Everybody agree? You throw it, that's it. Any method called should try and catch this method now. It becomes a check exception, right? Alright? So I can throw an exception. Public void set radius. Do you remember the circle class that had set radius, get radius? I'm going to say throws illegal argument exception. Illegal argument exception is built in Java, so you don't need to create any class. If the radius is bigger than 0, you find. Else what? Throw new illegal argument exception. So exception is not all bad, alright? Sometimes you're using it for business logic, right? So take a look at this one. If a circle object calls the set radius and passes a negative number, what will happen? Exception will happen and you have to catch it. So in many cases they use exception for business logic, alright? It's not all bad. Try, you can put some statements, one or more than one, and then you can say what? Catch, catch, catch. How many? As many as you want. Are we good? You have a method that calls another method, and this one calls another method, and this calls what? Well, actually it doesn't call any method. So 3 calls, right? Let's say this one throws an exception. Where do you go? An exception is thrown in this method 3. So where do I go? I go here. I check if it's x3. If it's x3, I process. And then where do I go from here? Huh?
No, you.
Backward.
You skip it.
Depends. If exception is being thrown here is x3,
So you.
do I catch it?
Yeah, that's.
Do I execute statement 6 too?
You need to.
Why not?
Yeah, use it. You take, that's it.
Yeah, you execute statement 6, right?
Oh, yeah.
You execute statement 6.
Yeah.
But if this method 3 throws an exception which is not exception 3 type,
Then you go back.
then
and
you
check.
bubble back to caller.
Yeah.
Do you execute statement 6? No, you don't. So if you catch it, you continue after. If you don't catch it, you have to go back to the caller. Now this caller, it comes where? The exception comes here, right? Again, it comes here. Is it exception type 2? If it's exception type 2, it catches and processes it, and then executes statement 4. If it's not type of an exception 2, it goes back to the caller. If it's an exception 1 type, it processes and executes what? Statement 2. If it's not, it goes back to the caller. Right?
So it goes until it finds, until it catches the exception.
Or,
Or, yeah, if it doesn't, then it goes.
yeah, it goes out of the main and it's end of the story. So we have to catch this exception on its way back to the main. If it gets out of the main, that's it.
But don't you put the catch exception, like let's say exception number 3 will be something like out of bound, but in the end you have to put like try catch exception
Where?
after statement 6.
It's up to you how you want to put the exceptions here. If you catch it, you process it. If you don't, you bubble up back to the caller.
So no, you were saying that the order of throwing the exception is also important. You have to.
No, order not of throwing exception, order of catching them.
Yeah.
Yes, but you have just one catch here. So if it matches, it catches it. If it's not, you jump back to the caller. If it catches it, you process it. Otherwise, you go back to the
No,
caller.
what I'm trying to say, if we put in the end catch exception,
End means where?
like in after statement 3, if you always like after trying to catch all exceptions, we just put the bigger F to catch it. It will always catch it, right? Like if the
Yeah.
exception
Yeah.
is kind of like a safeguard, then you know you're gonna get.
Yeah, if you put an exception, but this is exception 3, it's not exception. If you
No,
put
I
exception,
understand.
yeah, it will catch it. And that's end of the story. So what will happen? Let's say this throws an exception 3. What will happen?
Which one? The invokes number 3 and catches exception 3, then executes statement 6, and that's it.
That's it. you got it. No, it's not the end of the story yet. We're going back to the caller, and then what will happen? No. Statement 3.
Statement
yeah,
3.
And then?
Yeah, and then
Statement 4. And then go back to the caller.
And statement
Statement
1,
1,
statement
statement 2. Right? So are we
That
good?
would confuse me.
Now it's not
Well, now,
Okay. So we know what's happening, right? You bubble up the exception, you catching it. If you're not catching it, you bubble up to the caller, and you keep going. If you catch it, then you continue like a normal process, and then you call back to the caller, you go through a normal process, because exception is caught there. Are we good?
Yes.
Alright. Catch or declare check exception. So if a file does not exist, throw new exception. So when I say throw new exception, I put throws I exception here. Now I have a checked exception, right? Any method that calls P2 should destroy a catch. Or declare to throw an exception in the header. Because that column might not be main, might be another.
Yeah, yeah.
Right?
Yeah.
And the header. So if you don't want to catch an exception, a checked exception, you have an option to what? Declare it on the header that you're going to throw an exception. You good? So public void, so let's take a look at this one. void P1, try P2, catch exception. So is that okay? Because P2 you already know. It throws a checked exception, right? Is that okay, Cole? Yeah. If you don't want to try and catch it, what do you have to say? I'm going to call it P2. I'm not going to try and catch the exception. I'm just going to say what? Those IO exception, which is this exception, right? We have two options to do that, right? Alright, so free throwing exception, we talked about it. You can have try some statements. If it throws an exception, will you catch it? Yeah, possibly perform some operation, and then you do what? You throw it again. And one other reason, see the layers that we discussed, can every layer throws an exception?
Yeah.
When you want to do something about that layer, and then pass that exception to another layer, and maybe that layer want to do something different, and you pass it again to another layer, maybe that layer wants to do something different, right? So every layer might handle the same exception differently, right? So you want to bubble it upward, all the way to all the layers. And eventually that class that I said will stop that there. We will not let it go to the main and get out, alright?
So that would be the class to handle all exceptions.
Yeah, it's an entry point. See, it is common sense again. These are design. We didn't discuss much design. That's another level of programming. When you program for 4, 5, 6, 7 years, by common sense you learn some design, but you're getting to a point that you have to design something properly, alright? It comes with experience and common sense, alright? It's not just reading and I'm a designer now. For example, the door. Can you put the door here? Yes. Can you put the door in the middle? Yes. Can you put the door in the ceiling? Yes. You can put the door many places, right? But which one is the best design? It comes with some common sense, right? In programming, you design it for a couple of reasons, and what consideration you have to have for design.
User?
Huh?
I mean, user flexibility?
That's a business case. We're talking about pure programming side. What is a good design? Huh?
Easier to maintain?
That's 80% of the design. You can easily change the code. You don't need to spend months to change the code. You can change it in days or weeks, but not months or years, alright? If I separate the functionality based on the layer, tomorrow your boss can come and says, I want another button here. Will you touch this layer? Will you touch the middle layer? Will you go in the UI? Yes.
You already have package where you go.
Yeah, you know where to go, and you limit the change to that package, to that code. If you scatter everything all over the place, not only is it difficult to change, you possibly introduce a regression bug to this problem. See, this is very risky in application development, and it's a day-to-day life. As soon as you change something, if it's not good design, you possibly introduce another defect on another section. And very typical. Every company deals with that. They change something, they break something else. They change something, they break something else. And the more horrible design it is, this can happen more frequent. Right? So the best design is to be easy to maintain that. Now take a look at this design I told you. If everything goes through one class, every flow of the program goes to one class, and that class responsibility, sole responsibility to deal with exception, isn't it easier to deal with exception in general?
Yeah, but I'm kind of confused how you can make those exceptions to other things.
You bubble up those.
Like, let's say I'm going to have a business logic some other class, and to throw, like, one of the methods will throw the exception. I will throw it, like, rethrow it to that class, right?
You keep rethrowing until it reaches what? That class, because the flow came through that class, right? You call the method on this class, this one called another one, this one called another one. So if this one throws an exception, can you bubble up all the way back?
So do you put, like, throw EX, and in that class, were you gonna, like,
No, that one cannot throw anymore.
No, I know, but, like, you put try catch block for that one, for that exception?
For all the exceptions that you want to handle, yes.
So in that class, you can actually change the way you want to handle it.
Yeah. That's the only class you go and change whatever you want about exception.
You don't put anything there, like in the business logic method?
You can put there if you want.
But it will be.
But then you have to read through it, and I know that this is the responsibility of this class, to eventually catch it and show a message to the user what's going on.
But that's why you said it's easier to change in one place.
Yeah, it's easier to change one
Okay,
place.
now
Your whole writing code should be, can I change this code easy? Of course, the dynamic part of the code, not something that is always fixed forever, right? So don't go too extreme. I'm gonna change everything. No, not everything will change about an application. But there is a dynamic part that keeps changing. Customer wants more, customer wants more. Can you change your code easy? If you don't, if you cannot change your code easy, you wrote a bad code. There is no way that code will not change. Alright?
right now I'm kind of confused. Should we like throw exceptions in every method? And like,
Yeah. So exception from every method.
What if it, I have a question, so like, if my code is working well, then what's the point of exception?
How do you know your code is working well?
Because if I can execute everything,
What?
if I can execute everything that is required.
But if you cover every case.
yeah, what if you want to change something in the code and it might throw the exception?
But it's only the
Yes, first of all, you don't know how sound is your code by running a couple of things and it's working. Doesn't mean you covered all the test cases.
That's why I released alpha, you know, beta's coming next.
Yeah. But even beta has a bug.
Put them
Right?
on pause jail till you get out of here.
So you cannot be sure about the code. Always code has bugs, so you always have to catch it. And by the way, as you said, you change it. As soon as you change it, you possibly introduce some other problems.
Okay.
But in the book it says it's also bad to throw exceptions.
Forget the book. I'm here. You think who wrote the book?
Well, that's what you should start from.
God of Java.
First class, you
Someone
said
like
we
you
got
wrote
the
the
book.
book.
It's really
Yeah, right?
I know.
I just want to get a seat.
I'm just
Yeah,
trying to.
he's on my team.
I'm just trying to get a seat.
All right.
He's
Yeah.
on my team.
30 minutes to get to the break. All right.
I'll do a paper.
So let's take a look here. You tell me what will happen. Suppose no exception in the statement here. Where you jump?
Final.
Then.
Next statement.
Now, statement 1, statement 2, statement 3. Suppose statement 1 doesn't throw an exception, but statement 2 throws an exception of exception type 1.
Exception one. And final statements. And the next statement.
Now, exception is thrown in statement 2, but it's exception type 2. Now, this one is a bit tricky. So, what will happen?
second
Go into exception two.
So, it goes to second exception? Alright, and where it goes from there?
It's gonna throw it.
We're handling it
But it throws it in.
by
the-
throwing it. So, where it goes
So
from
you
there?
go to exception one?
It throws it.
Tell me the flow now. Okay, I caught it. I handle it, but there's a throw here. So, where should I go from?
Or you go to another method?
Go back up.
You go to final
Final.
statements.
Try.
You go to final statements.
You go to finally always to execute this, and then you throw it back to the caller. Finally always gets executed, regardless you throwing an exception, not throwing an exception, that should be executed. And then I come to throw X, and I throw it back to what? To the caller of this method. Will I execute next statement? Not anymore.
Because you have to
I'm
go,
throwing it
when you throw, you have to go.
Yeah, I'm throwing it back. Everybody understood this? Statement 2 throws an exception of type 2. It's not exception type 1, exception type 2. So I handle it, I execute it finally, I re-throw it back to the caller, I will not execute the next statement.
So finally happens as soon as the exception is caught, it goes straight to finally,
You
or?
go to-
No.
So it ignores all throws and does finally.
The finally gets executed before you re-throw it back to the caller.
So it's just before.
It's just because you're rethrowing it, you have to.
See, before you send it back, you want to finish your work, right? So you do the finally, and then you rethrow it. Because if you go back, that's it. The finally cannot get executed anymore, right? Because it's part of the stack of this method, right? Everything is part of the stack of this method, right?
Yeah, I just wanted to make sure, so, because you can have a lot of things in your catch can do some stuff. So it's gonna do everything that's in the catch, then go to final, and then come back to.
No, we cannot do catch, right? Just one catch, right?
Yeah, but in the catch, I can have.
Yeah, if you catch, you have 50 statements.
That's what I'm saying.
You finish the statements,
Statements, and
then you execute the finally, and if you need to retro will be the end part.
Okay.
Good?
So, if you don't find any error or anything, you don't have to.
Okay, so if you don't find any error, what will happen?
Straight to finally.
Go to finally.
Finally,
And then next
finally, and then.
Next statement.
No, next statement. That's after the final, right?
So, yeah, as long as, I mean, if you find an error, it will throw that, like, bubble up, like.
Depends.
Whenever it's in.
Where
the
I
catch.
find it, what type of exception is it? So the type of exception, okay, if I find it here, exception 1, then what will happen?
It's just gonna.
Go to
If it's an exception 1 type,
It's just gonna catch.
will it handle X?
Yes.
Will it execute finally?
Yes.
Will it go to next statement?
Yeah.
So it really depends which statement and what exception. But you have to just understand the flow. You catch it. If you need to rethrow, finally always gets executed before rethrow, and the other statements will not get executed if you're rethrowing it, right? Cautions when using exception. Exception handling separates error handling code from normal programming tasks, thus making program easier to read and to modify behavior. However, the exception handling usually requires more time and resources because it requires instantiating a new exception object, rolling back the call stack, and propagating the error to the calling method, right? So more work, but you have to do it. An exception occurs in a method. If you want the exception to be processed by its caller, you should create an exception object and throw it back, right?
That's what you said.
You always have to do it, to me, to my opinion. If you can handle the exception in the method where it occurs, there is no need to throw it. The reason I'm saying is because let's look at a couple of methods there. You remember scanner? Scanner.
We didn't use it for.
Oh, you forgot because you didn't use it for a week?
Hey, now, I just use text.
Okay, scanner. Now you should be able to read everything about this documentation. There's nothing that you don't know. Do you know final? Do you know extend?
Yes.
Do you know implement?
Yes.
Do you know generics?
Yes.
Alright? So you can read everything, and these are what? Constructors. These are what? Methods. So let's look at okay, let me go to the double. Alright, we have parse double. Parse double, right? You know what static means, right? Is it throwing exception?
Yep.
So, if you look at the methods on these APIs, almost all of them throw the exception. So, now if you want to compare it to the book, which one is more valid? This one or the book?
Well,
That one.
I actually asked you about that. Should we go and check?
No, I'm just telling you, even if you want to go in this comparison, these are the people who wrote the Java, so they know better than people who wrote the book, right?
Probably, I mean, I also want to understand something.
No, and use your common sense sometimes. Sometimes, Does it make sense or it doesn't make sense? You know, people don't come with this stuff if it doesn't make sense. And if
That's why I said, should we like go and look it up, an API, before throwing it?
you know that most of them throws an exception, so just catch it in an exception. If you want to separate them, then you have to go and take a look what kind of exception is called.
But in the project.
See, if you want to put like, let's say, someone puts a social security number, right? For example, in that GUI, it's a string and you want to parse it, right?
Yeah.
And they put an email address too and lot of the information, right? Can you bundle all of them as one exception? Yes, and you give a generic message. Something went wrong in your entry. Or you can just say, something went wrong in your social security. Something went wrong in your email address, right? So then you have to separate all these exceptions based on that data you get, right?
And then you throw them back on the class.
You throw it back there and then you pop up a message. That class will handle all those messages.
So the message will pop up in the UI, the GUI, saying like SS, so if it is SS and wrong.
The message, see, this class will form the message, right?
Yes.
Form the message and will pass that message back to what? To the UI layer. And the UI layer, you can also have another class that takes all these messages and pop up a message for you.
Like another
So you have to create another message.
Yeah, for example, if it's this type of an exception, show it flashy. If this is type of exception, don't show it flashy, alright? All depends on your design. I'm not requesting, I'm not asking for all this stuff, but it's a good practice right now if you have time to go through it.
Yeah.
Because that differentiates an entry-level programmer with an experienced programmer. Entry-level programmer writes something that works. It's difficult to change, a headache. Experienced programmer by experience figures out if you write it this way, and sometimes it's difficult because if you don't write it first, if you have no clue, then how you know it's difficult to change? When you write one time, 1 year, 2 years, and then figure out, oh, from now I'm going to write it this way because it's easy to change. Huh? More time? Than a couple of years?
No.
Yeah, functionality is just one aspect which is expected in this course. But while you're writing, why you don't enhance it so you go faster in your career, you pick the programming career that write a code that is fast, consume less memory, and easy to maintain. These are three things we always have to think, and maintenance is very important. Then speed, then memory usage.
But does it come with experience when you already tried it the first time in the basic way, then when you do the same task, you already have experience?
Yes.
What do you mean about how fast? Like,
Huh?
you said how fast. How do you mean by how fast? Like,
How fast do you execute the
How fast the program is
yeah,
executed?
is that you talk about the execution?
Yeah. How fast is it executed? Yeah. I mean, computers are fast here, but if you work in a company like Amazon, even milliseconds count. So you want to search an inventory of different items in different locations. Yeah, if you want to write a code that is slow, it doesn't work for them. That's why when you go for Amazon, they're not going to ask you just questions and it works. It should work good, fast. So they tell you, yeah, it works, but it's a bad solution. Okay, so let's keep going for 15 more minutes. Alright, so you already know about the exception and when to use exception. When should you use the try catch block in the code? You should use it to deal with unexpected error condition. Do not use it to deal with what? Simple expected exception. So reference, this is a reference. You can throw what? No point of exception, right?
Yes.
Don't say in a try, catch that no point of exception. What you have to do here to make sure that everything works. You just check the ref value with what? No, and if it's not no, then you call a toString on it, right? And if it's no, maybe you want to say reference is no, right? So exception is really not you should not deal with business logic and all those stuff in the code. Exception for just handling unexpected errors, right? that a good code? No, it's not a good code. Because it uses exception for not its purpose, right? We good? No, 15 more minutes. See, you have to replace it with this one because I know that this might cause a problem, right? Because that might be no. I'm not putting in an exception. Exception is for sometimes, most of the time, unexpected stuff. So I'm going to rewrite it this way. Yeah, because I know it might be no, right? Why I need to use exception for that? Exception is not designed for this. Exception is designed for another usage, right? Alright.
But arithmetic, like divided by 0, we can still put if else statement. It makes sense because
Yeah, you can put it.
you don't have to throw the exception
Right.
because it makes sense.
Last thing, sort of last thing, you can create your own exception. And you're going to do it for your project. For example, it's not good practice, right?
Okay.
See, you can use this project to put it where? On the GitHub and show it to what? The prospect employer, right? If you write a crappy code, better not to show it then, right?
It's better not to show it.
Yeah. So you want to write something that you can brag about it. Not the guy says, what the heck is this, right? So maybe you want to write the code in a way that you can show and use that leverage for getting the job, right? Not using against you. Oh, this is bad. I'm going to get the job.
No, maybe you said, well, I was starting from this, and now I'm that.
Or you can keep it there and create a new one to like compare those two, right?
Yeah, sure. You don't do even what I tell you in this class. After class, you want to go and create another project and make it better.
You never know.
Possible, less than 5%. That's human nature. If there's no pressure, people don't do stuff.
So true.
You want to read a book? If there's no pressure, today, tomorrow, tomorrow it takes 2 years to read one book, right? Okay, so let's discuss this, how I can create an exception. Again, exception is not bad. Many times they're using it for what? For business stuff. For example, you work for a bank and you want to create account not insufficient funds. Insufficient funds. It's not an exception yet, but you already know about what? The class hierarchy of exception, right? So anything to become an exception, what should happen? It should extend from exception. So you say what? You can extend from other ones, but why not extend from what?
The other ones are expected already.
Extend the exception, right? Now I'm gonna create a constructor. And you already know the constructor, right? I'm going to put a message here. And then you already know the super, right? What is super?
Super.
Yeah.
The Superman.
The Superman?
Captain America.
Alright.
Endgame.
Okay.
Avengers Endgame. Let's go.
So, now the one is here.
You don't know.
Alright, so I created a class, extends from exception and constructor that gets a message and does what? Pass it to the super class. And what is the super class? The exception. Okay, if you work in a company, you see a lot of these exceptions that shows a separate scenario, a business scenario, right? So what they do here in the bank, let's say you work in the bank, and where's my main? And we write in program for ATM, and you get the balance of the user or the withdraw. Let's say double withdraw. Alright? So you get that from the ATM machine, right? And now you have it in the code, and withdraw, for example, the one person wants to withdraw $1,000, right? And let's say you already have the balance, comes from the database. So the balance of the user is what? Let's say it's 500. Can you withdraw 1,000? No. So you come here and say if what?
Withdraw is greater than balance.
Withdraw. Withdraw bigger or bigger?
Bigger. Balance.
Then
Throw
throw
exception.
new what?
Balance. Pending.
Oh, sorry, my bad. Account. Insufficient, or you can say what here? Because you have to pass a string, right? And you are throwing this, right? So I have to put it where? In the header?
Yeah.
Or try and catch it? Okay, so actually this is a bad example because I can have a withdraw method, right? And then put the double here. Withdraw is a withdraw amount, right? Then I'm gonna go to this method and I'm gonna put this.
Don't you need to pass balance as well?
Yeah, you have to do this stuff. I just try to quickly, quick and dirty just to understand what's going on here. Okay, I'm throwing it. Now it's a check exception, right? So what should I do?
You put it in the header.
Throw, right?
Yeah.
Now here, the ATM machine says withdraw. Okay, I made a mistake on that thing. Withdraw, and I passed this one. Alright, should I try and catch that one now?
Yes.
Yes. So try and what? Catch. And I can say separate them based on what? Different exceptions, right? And system out, print line. If I say X, you think what gets printed?
The string of the
This one. If I run this, do I get an exception? Yes.
sufficient 1,000. But it doesn't say nothing.
It doesn't seem what?
Should be better method than
Yeah, of course. You want what? I write the whole ATM machine code for you here?
Yeah.
I'm just giving a quick example.
Well, you said we have you, not the book. So you could do it. But you won't see what you want me to do.
Yes, we have a limitation of time, so I can't write everything perfectly. I'm just giving you a sample of code, how it works. I create my own exception. Each method can throw different type of exception based on a different type of business scenario. And your class here will catch all of them, right? So tomorrow, if your boss says, oh, in this scenario, we have to also show a message, then you create a new exception, and based on that new exception, throw it, and add that catching here, and then add another message to the next layer to format that message in another form of message, right? See, not only is it easier to maintain, in a company, there are not one or two people working. The IT team or dev team can be like 100, 1,000, 50, alright? Definitely more than 2 or 3 people. And what? Not everybody wants to work on one layer. Some people work in here, some people work in here, some people work on the back end part, some front end, some people shift the position, one sprint they are here, one sprint they are here. And you know what is a sprint, right?
Yes.
Yeah.
Alright. If you don't, go and study. Alright, so
Like 30 days thing.
yeah. Are you trying to get your certification or no?
Yeah.
Agile.
Agile, yes. Alright, don't worry about the assertion. We can skip the assertion. One last thing and we're done with this chapter, alright? Don't worry about the assertion 5. You write on a database, you read from a database, data is huge there, there are some constraints there, it's more structured database, right? Sometimes every application, most applications, need to write some small pieces on a file and read from it. If the data is too small, they're gonna write 5 most of the time, right? How they write a file? You first of all, we have a file class. And if you look at the file class, it's interesting because you already know how to interpret all this stuff. These are what? These are constructors. By the way, I don't know every class in Java. I just go and read about it, what it is. So I can read here. File. Can I create an object of file? Yes. So read about it. Create a file object for the specified path name. So you give the path name here. It creates that file object for you. Alright? Now, you can point it to an existing file or a place that there is no file there, right? Then you can call this, is it a file? Is it exists? Exists. So if you say exists on a file and it's not there, what it gives you? False. If it exists, it returns true. And then you can run some of these APIs on it and gives you different things. For example, if the file exists, can you say the length of it? Yes, you can do that, right? Then you remove it. Rename, do we have delete? Where is it?
Bottom, under, above rename two.
Above rename, delete. So can I give you a Java code and say run it? And then suddenly your whole C drive is gone.
Yes. Your whole
And be careful, when you write with D with file, you have to be careful because I know Java is platform independent, but file system is not platform independent, right? So if you come here and say C drive, blah, 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 will that work on your Mac or Linux or Unix? No. So you have to be careful about that you have to use relative paths. From where I am, I want to go one level up or one level down. Yes.
So the path name is the file extension or no?
Yes.
It
The
is?
path name is not the file extension, the path to that file.
Path to,
Yes.
like.
So if you run your Java code, wherever you run your Java code, if you say, for example, data.txt, if you write it this way, where is it looking for? Where?
It's looking for the text.
Yeah, but where? On the same place that your main is running.
Okay, so when you
So it's
put
gonna
the
be in the
path.
package.